The risk calculus for the hacker has changed, so they're extending their toolbox, which detection and defense tools can help prevent lateral movement. What can make lateral movement harder? Hi, this is Carsten from Hacking Matters, where each week we explore the opportunities in cybersecurity. Today we're continuing our discussion on the hacking journey through a corporate network. In a previous video, we looked at initial intrusion, how the hacker gets a foothold into the organization. Today we look at what the hacker does with that foothold and how they extend their access through lateral movement throughout the environment until ultimately achieving the hacking goals. Parts of this lateral movement are similar to the initial intrusion, where the hacker looked for, found, and exploited vulnerabilities, both known vulnerabilities in standard software and individual vulnerabilities in web applications. So those are also common on the internal network. However, the risk calculus for the hacker has changed, so they're extending their toolbox to mostly move away from exploiting vulnerabilities for two reasons, really. First, it's a lot more noisy to try to exploit vulnerabilities on the internal network. On the internet, this happens all the time. It's basically just the noise of the internet that an organization would measure. But once you see vulnerabilities being exploited on the internal network, there's a lot more reason for concern and reason to investigate incidents. So for that reason, hackers are a lot more careful using exploits on the internal network so that their initial access isn't detected and revoked. The second reason why hackers would move away from vulnerabilities onto some other techniques is that many more opportunities are open to them. They have more access to more interesting information that can give them lateral movement opportunities without having to exploit vulnerabilities. Those additional hacking sources are what we want to focus on today, as well as the question of which detection and defense tools can help prevent lateral movement. The lateral movement part of a hacking journey typically takes weeks. Even in relatively weak organizations, there's a lot of waiting, sitting around, waiting for software to log in, waiting for admins to log in, so you can go through memory scraping, credential harvesting, and logging into other systems. Now, those are highly parallelizable activities. An initial access broker would hack into multiple organizations at the same time and then basically do this waiting game in all of these organizations at the same time, slowly moving forward in parallel hacking journeys. But for you as the defender, you have several weeks to respond to hacking, because it will take several weeks for the hacker to leverage from initial intrusion all the way to full access into your organization. Imagine the hacker has an initial foothold on some server with one leg on the internet and one leg on some internal network. Mostly those are uninteresting servers, because the most uninteresting servers are the least well maintained and hence the easiest to hack. But there isn't usually much interesting data on those. So suppose the hacker does have access to one of those servers now. They can use that access to scan the internal network and exploit vulnerabilities. But that's specifically what we said, probably the risk calculus suggests they shouldn't be doing. So the hackers mostly go through three steps. Once, they use either their own tools or built-in tools to scrape the memory of the server that they already have. Second, they look for credentials in the memory. And they do this time and time again because the memory content, of course, evolves over time. And at some point, new credentials will pop up in memory. Thirdly, they will use those newly found credentials to log into other servers and to start the whole process again. Again, scraping the memory, looking for credentials, and then using those credentials to log in yet further, eventually hitting more interesting servers with higher and higher privileges. So why are credentials found on servers? Specifically in Windows, when you log into a server, either as a human or as a machine-to-machine account, your credentials are sent to that machine, and in fact, they're cached onto the server side where you're trying to log in. So anybody who has already hacked that server now has access to the credentials. And often, of course, you use the same credentials to log into different servers. And many accounts that log into servers periodically have relatively high credentials. Imagine, for instance, a patch management solution. This will log into each server one by one, check the patching status of installed software, and install updates as necessary. Those actions require relatively high privileges to a large number of servers. So if you're sitting on any one of those servers, scraping the memory, eventually you'll be presented with a set of credentials that you can use to log in everywhere where this patch management software logs in and abuse it to scrape more and more credentials and eventually hit something of high privilege, say a domain controller. Now, these memory scraping techniques, they're mostly focused on Windows. And most organizations, of course, rely on Windows and Active Directory as the backbone for authentication. But other technologies are affected as well. Linux enterprise grade often has identity management solutions that have similar weaknesses, as do some middleware software commonly found in organizations. So worry most about Windows, but you're not necessarily on the safe side, even if you don't use any Windows at all, because you need some kind of an identity solution, and most of them have similar pitfalls. Once the hacker has access to a new server, they try to create persistency by way of installing either a piece of malware on the server or using existing tools, living off the land to basically make themselves stay on the server, even if it's rebooted. Eventually, the hacker has completed their lateral movement in that they have access to servers now with interesting files or highly persistent access for whatever goals they have, either to embed themselves into that organization for strategic goals, or more likely encrypt or steal files to cache out. Turning our attention to defense. What can the organization do to make lateral movement harder? Assuming that the hacker does not use any exploits. That is, continuously go through the cycles of memory scraping, credential harvesting, and accessing new servers, and going through this until finally they achieve enough access to cache out. There are at least 3 defense levers that are somewhat effective, and together would fulfill the goal of our hacking defense funnel. If you haven't seen that video, just as a quick recap, we said that it's good enough to prevent 80% of incidents, to detect 80% of incidents, and to handle 80% of incidents. So here we're in the detection stage. The intrusion has already happened. No more exploits are needed. Nothing of the sort can be prevented here in terms of intrusion. We just want to detect that it's happening. And 3 defense technologies together will probably help you achieve those 80% or above. The first is an EDR system. Now, EDRs are basically evolved virus scanners that are supposed to look for behavior more than signatures. The truth is somewhere in between. We did extensive research on this in 2022. Right now, the Q1 of 2023, we revalidated that those results are still valid. EDR tools in the market today do not primarily look for bad behavior. They look for suspicious actions in installing malware, mostly hooking, and they're trying to prevent hooking from happening. Hackers know that, and they can still install the malware by basically playing cat and mouse with the EDRs. But it does add effort. So if a hacker is purely optimizing for a quick opportunity to cache out, if you're using an EDR tool, you become less attractive to the hacker right away, by way of adding weeks to an already long hacking journey. EDRs extend already long hacking journeys by several more weeks. So they're definitely deterring hackers, at least impatient hackers. However, they're rarely given the opportunity to detect hacking. Hackers will see that an EDR system is in place, and they know how to circumvent it at additional effort. So turning our attention to the second defense lever, honeypots, or in modern lingo, deception technology. This is where you can really create opportunities for detection rather than just slowdown of the hacker. A deception technology basically puts fake credentials or fake systems onto your network that are not usually used by your staff. If a hacker ever uses one of these credentials or accesses one of these systems, it's a highly suspicious signal that you need to investigate. Honeypots and deception technologies come in all flavors, from open source and free tools to very expensive enterprise tools. They mostly achieve the same, providing you an opportunity for a strong signal to investigate. That investigation still needs to be done by you. So these are not silver bullets that solve hacking for you, but rather they're good starting points if you already have a good incident response capability. Here's one simple way to start with deception at basically zero cost. You're creating a highly privileged account within Windows Active Directory, say a domain admin account, and you're making sure that the credential for this account is cached on all the servers by way of logging in there once. Then you set the lock-on hours of that account basically to never. So even if you have the credentials of this account, you can't log in anywhere. However, the hacker doesn't notice. They'll come across this credential, try to use it, giving you a very reliable signal to investigate. So deception doesn't have to be a lot of effort, and it certainly doesn't have to be expensive, but it is important as part of your defense portfolio. That's the second technology that in concert with EDR now gives you a slowdown of the hacker, adding several more weeks, and the possibility to actually use those weeks to do meaningful incident response. The third defense lever falls into both categories. It is a slowdown for the hackers and an opportunity for you to create good signal to investigate. And this falls into the category of zero trust. It's a relatively blurry term that different people mean different things by. And we have a separate video to really go into the effectiveness of zero trust and what are its core components. For the purpose of today's discussion of making lateral movement more difficult, we only want to zoom into one specific aspect of zero trust, and that is decoupling user identities from device identities. And usually you would be surprised to find that both of these are in the same inventory. Nobody who would build an enterprise architecture today from scratch would do it like this anymore. So decoupling these two inventories is one slowdown measure, as well as your opportunity to detect more activity because you're forcing the hacker to do more scanning again. How do you decouple those? Well, if you want to stay within the Windows context, you can use two different Active Directories. And many of you will already be undergoing a cloud migration. So you're already migrating some of your identities into, for instance, Azure ID. And so why not decouple it at that stage? For instance, move all your user identities into Azure ID and leave the device identities in your more traditional Active Directory, or the other way around. You can also migrate onto two on-premise Active Directories, of course. Whichever way, make sure those identities are decoupled. So those are the three defense levers to make lateral movement not impossible, but much more difficult. EDRs to slow down hackers. They're easy to circumvent at additional cost, and that additional cost is really what you're looking for to get additional time for detection. Secondly, deception, honeypots, is what you use that additional time for. You want to create signals to investigate. And thirdly, zero trust, and specifically decoupling of user identities and device identities, gives you both a slowdown for the hackers because they don't get all the information delivered for free anymore, and an additional opportunity to find hackers and investigate their activities by forcing them to scan more on your network. Between the three defense levers, you'll be able to detect 80 or more % of hackers in the lateral movement stage. That's not to say 80% of hacking activity, because each hacker will go through many steps of hacking activity on their week-long journey. So in aggregate, you want to be able to detect 80%, the more noisy 80% of the hackers, and maybe not the 20% of most stealthy hackers, which really need some more advanced technologies than we're discussing today. If you do achieve the 80% of detection, though, you're perfectly fine as per our discussion in the hacking defense funnel. If you haven't watched the discussion on the hacking defense funnel yet, that's probably an interesting video for you to go to. Other videos to complement this one are the one in the hacking journey before, on the initial intrusion, as well as afterwards, post-intrusion, and what you need to do in incident response. We also linked to our EDR research from 2022 showing how these systems can be circumvented, as well as additional videos on zero trust and honeypots. If you have any questions or comments, let us know, and we'll see you next time.